Introduction to mobile app development. Mobile app development involves creating software applications that run on mobile devices like smartphones and tablets. These applications can be pre-installed on devices, downloaded from app stores, or accessed via mobile web browsers. The field encompasses a wide range of skills, from user interface design to backend integration. Understanding the core principles is crucial for anyone entering this dynamic industry. This course will guide you through the entire process, from initial concept to final deployment. It focuses on practical skills and theoretical knowledge necessary for success. The demand for skilled mobile app developers continues to grow rapidly across various sectors. The mobile app landscape is diverse, offering opportunities in native, hybrid, and web-based app development. Each approach has its unique advantages and disadvantages, influencing performance, development time, and user experience. Choosing the right development strategy depends heavily on project requirements, target audience, and available resources. A solid understanding of these distinctions is fundamental before embarking on any development project. This introductory section lays the groundwork for subsequent, more specialized topics. It provides a high-level overview of what to expect and the journey ahead. We will explore these different approaches in more detail later in the course. Evolution of mobile technology. Mobile technology has undergone a remarkable transformation, evolving from simple communication devices to powerful, multifunctional computers. Early mobile phones primarily offered voice calls and basic text messaging capabilities. The introduction of smartphones, beginning with devices like the original iPhone, revolutionized the industry by integrating advanced computing power, internet connectivity, and touch interfaces. This shift paved the way for the app economy, enabling developers to create diverse applications. The rapid pace of innovation continues to shape how we interact with technology. Understanding this evolution helps contextualize current development trends. It highlights the constant need for adaptation and learning in this field. Key milestones include the advent of 3G, 4G, and now 5G networks, dramatically increasing data speeds and enabling richer app experiences. Improvements in hardware, such as more powerful processors, higher resolution screens, and advanced camera systems, have also expanded app capabilities. The rise of mobile operating systems like iOS and Android created standardized platforms for developers. These advancements collectively fueled the explosion of mobile applications. They transformed industries from entertainment and communication to finance and healthcare. This ongoing evolution ensures that mobile app development remains a cutting-edge and ever-changing domain. Key mobile platforms: iOS and Android. The mobile app development world is largely dominated by two major operating systems: Apple's iOS and Google's Android. iOS powers Apple's iPhone and iPad devices, known for their premium hardware, tightly integrated ecosystem, and consistent user experience. Android, on the other hand, is an open-source platform used by a vast array of manufacturers, leading to a diverse range of devices and price points. Each platform has its own development tools, programming languages, and design guidelines. Developers often choose to target one or both platforms based on their project goals. Understanding the nuances of each is critical for effective development. This duality shapes many decisions in the app development process. Developing for iOS typically involves using Swift or Objective-C with Apple's Xcode IDE. The iOS ecosystem emphasizes strict design principles and a curated App Store experience. Android development primarily uses Kotlin or Java with Android Studio, offering more flexibility in device compatibility and distribution. While native development provides the best performance and access to device-specific features, cross-platform frameworks aim to bridge the gap. These frameworks allow developers to write code once and deploy it on both platforms. Each platform presents unique challenges and opportunities for developers. Making an informed choice between them is a key strategic decision. Understanding mobile app ecosystems. Mobile app ecosystems extend beyond just the operating system and devices. They encompass the entire infrastructure supporting app creation, distribution, and consumption. This includes app stores, Apple App Store, Google Play Store, developer tools, SDKs, software development kits, APIs, application programming interfaces, and monetization platforms. Each ecosystem provides a framework for developers to build, test, and publish their applications. Understanding these components is vital for navigating the mobile market effectively. It dictates how users discover, download, and interact with apps. A robust ecosystem fosters innovation and provides resources for developers. These elements collectively shape the success potential of any mobile application. The app stores act as primary distribution channels, enforcing guidelines for app quality, security, and content. Developers must adhere to these guidelines to ensure their apps are approved and visible to users. SDKs and APIs provide access to device features, cloud services, and third-party functionalities, significantly accelerating development. Monetization strategies, such as in-app purchases, subscriptions, and advertising, are also integral parts of these ecosystems. A comprehensive understanding of these interconnected elements allows developers to optimize their app's reach and revenue. It ensures compliance and maximizes user engagement. This holistic view is essential for long-term app success. Mobile App Development Lifecycle. The Mobile App Development Lifecycle, MADLC, is a structured process that outlines the stages involved in creating a mobile application, from conception to deployment and maintenance. It typically includes phases such as planning, design, development, testing, deployment, and post-launch support. Following a well-defined MADLC helps ensure that the app is built efficiently, meets user requirements, and is of high quality. Each phase has specific deliverables and objectives that contribute to the overall success of the project. This systematic approach minimizes risks and streamlines the development process. It provides a roadmap for teams to follow. Adhering to the MADLC is crucial for managing complex projects. The planning phase involves defining the app's purpose, target audience, and core features. Design focuses on user experience, UX, and user interface, UI, creating wireframes and prototypes. Development is where the actual coding takes place, bringing the design to life. Testing ensures functionality, performance, and security across various devices. Deployment involves submitting the app to respective app stores. Finally, post-launch support includes bug fixes, updates, and performance monitoring. Each stage is iterative, allowing for feedback and adjustments. This cyclical nature ensures continuous improvement. Effective management of these stages is key to delivering a successful app. Planning and strategy for apps. The planning and strategy phase is the foundational step in mobile app development, crucial for defining the app's vision and ensuring its long-term success. This stage involves extensive market research to identify target users, analyze competitors, and understand current trends. A clear definition of the app's unique value proposition and core functionalities is established. Business objectives, monetization strategies, and key performance indicators, KPIs, are also determined during this phase. Without thorough planning, projects can easily derail, leading to wasted resources and missed opportunities. Its initial groundwork sets the direction for all subsequent development efforts. It ensures alignment with overall business goals. Effective planning is the cornerstone of a successful app. Key activities in this phase include creating a detailed project scope, outlining features, and prioritizing them based on user needs and business impact. Developing user personas helps in understanding the target audience deeply. Crafting a comprehensive technical specification ensures all stakeholders are aligned on the app's architecture and functionalities. Risk assessment and mitigation strategies are also formulated to address potential challenges. This strategic blueprint guides the entire development team. It ensures that the final product meets both user expectations and business requirements. A well-defined strategy minimizes rework and maximizes efficiency. User Experience UX Design Principles. User Experience UX design focuses on enhancing user satisfaction by improving the usability, accessibility, and pleasure provided in the interaction with a product. For mobile apps, good UX is paramount, as users expect intuitive and seamless interactions on small screens. Key UX principles include understanding user needs, creating clear navigation, ensuring consistency, and providing timely feedback. A well-designed UX anticipates user behavior and guides them effortlessly through the app's functionalities. It aims to solve user problems efficiently and pleasantly. Poor UX can lead to user frustration and app abandonment. Therefore, investing in robust UX research and design is critical. Core UX principles involve user-centered design. Always prioritize the needs and goals of the end user. Consistency. Maintain a consistent look, feel, and behavior across the app. Feedback. Provide immediate and clear feedback for user actions. Efficiency. Design for optimal task completion with minimal effort. Accessibility. Ensure the app is usable by people with diverse abilities. Learnability. Make the app easy to understand and use for first-time users. These principles guide designers in creating engaging and effective mobile experiences. They ensure the app is not only functional, but also enjoyable to use. Implementing these principles leads to higher user retention and satisfaction. User interface, UI design for mobile user interface. UI design focuses on the visual and interactive elements of a mobile app, determining how the app looks and how users interact with it. This includes layout, color schemes, typography, buttons, icons, and other visual components. Good UI design is aesthetically pleasing, consistent, and guides the user's eye naturally through the app. It directly impacts the user's first impression and overall engagement. A well-crafted UI makes the app enjoyable and easy to use. It translates the UX principles into tangible visual elements. Effective UI design is crucial for attracting and retaining users in a competitive market. Key considerations in mobile UI design include screen size and orientation, designing adaptable layouts for various device dimensions, touch targets, ensuring buttons and interactive elements are large enough for easy tapping, visual hierarchy, using size, color, and placement to guide user attention, platform guidelines, adhering to iOS human interface guidelines or Android material design principles, accessibility, choosing colors and fonts that are readable for all users, responsiveness, ensuring smooth transitions and animations. By meticulously crafting these elements, designers create interfaces that are not only beautiful but also highly functional and intuitive. This attention to detail significantly enhances the overall user experience. It ensures the app feels polished and professional. Introduction to programming languages. Programming languages are the backbone of all software development, including mobile apps. They provide the instructions that computers follow to perform tasks. For mobile development, specific languages are favored, depending on the platform and development approach. Understanding the fundamental concepts of programming, such as variables, data types, control structures, and functions, is essential before diving into platform-specific languages. These core concepts are universal across most programming languages. Proficiency in at least one relevant language is a prerequisite for any aspiring mobile developer. This section introduces the landscape of programming languages relevant to mobile development. It highlights their roles and applications. Common programming paradigms include object-oriented programming, OOP, functional programming, and imperative programming. OOP, with concepts like classes, objects, inheritance, and polymorphism, is particularly prevalent in mobile development. Languages like Java, Kotlin, Swift, and C# are all object-oriented. Choosing the right language often depends on whether you are developing natively for iOS, Swift, Objective-C, Android, Kotlin, Java, or using cross-platform frameworks, JavaScript, TypeScript for React Native, Dart for Flutter. Each language offers unique features and communities. A strong grasp of programming fundamentals will make learning new languages much easier. This adaptability is a valuable skill in the fast-evolving tech world. Native development. Swift Kotlin basics. Native mobile app development involves building applications specifically for a single platform, utilizing the platform's native programming languages, SDKs, and development tools. For iOS, the primary language is Swift, developed by Apple, known for its safety, performance, and modern syntax. For Android, Kotlin, a statically typed language that runs on the Java virtual machine, has become the preferred language, offering conciseness and interoperability with Java. Learning these languages is crucial for developing high-performance, feature-rich applications that seamlessly integrate with the device's hardware and software. Native development provides the best user experience and access to all platform features. It is often chosen for complex applications requiring optimal performance. This approach ensures the highest level of integration and responsiveness. Swift basics include variables and constants, declaring and assigning values, data types, understanding int, string, bool, array, dictionary, control flow, using if-else, switch, for-in, while loops, functions, defining and calling reusable blocks of code, classes and structs, building custom data types and objects. Kotlin basics cover similar concepts: variables var and values val, basic types, numbers, characters, booleans, arrays, contraflow, if, when, for, while, functions, defining methods and extensions, classes and objects, object-oriented programming fundamentals. Mastering these fundamentals in either Swift or Kotlin is the first step towards becoming a proficient native mobile developer. These languages form the core of platform-specific app creation. Cross-platform development frameworks. Cross-platform development frameworks allow developers to write a single code base that can be deployed on multiple mobile operating systems, primarily iOS and Android. This approach offers significant advantages, including faster development cycles, reduced costs, and easier maintenance compared to building separate native applications. Popular frameworks like React Native, Flutter, and Xamarin enable developers to leverage existing web development skills or learn new, efficient languages. While cross-platform apps might sometimes have minor performance trade-offs or limited access to very specific native features, they are often a compelling choice for many projects. They provide a balance between reach and development efficiency. This method is particularly attractive for startups and projects with budget constraints. The choice of a cross-platform framework depends on various factors, such as team expertise, project requirements, and desired performance. React Native, based on JavaScript and React, is popular among web developers for its component-based architecture. Flutter, developed by Google, uses Dart and offers excellent performance and highly customizable UI. Xamarin, utilizing C# and .NET, is favored by developers with a Microsoft background. Each framework comes with its own ecosystem of tools, libraries, and community support. Understanding their strengths and weaknesses is crucial for making an informed decision. These frameworks continue to evolve, bridging the gap between native and web development. React Native fundamentals. React Native is an open-source framework developed by Facebook for building mobile applications using JavaScript and React. It allows developers to create truly native mobile apps, not just web views, by rendering native UI components. This means apps built with React Native offer a native look and feel, along with excellent performance. Its learn once, write anywhere approach makes development more efficient and streamlined. Philosophy makes it highly attractive to web developers already familiar with React. The framework boasts a large and active community, providing extensive resources and third-party libraries. Understanding its core concepts is essential for leveraging its power. React Native significantly speeds up development time. It offers a powerful solution for building cross-platform apps. Key concepts in React Native include components, building blocks of the UI, similar to React for web. JSX, a syntax extension for JavaScript that allows writing UI elements. Props, used to pass data from parent to child components. State, manages component-specific data that can change over time. Native modules, allowing access to platform-specific APIs when needed. Styling, using a CSS-like syntax for styling components. Mastering these fundamentals enables developers to construct complex and interactive user interfaces. React Native bridges the gap between web and mobile development effectively. It offers a productive environment for building cross-platform applications with a native feel. Flutter, Dart language and widgets. Flutter is an open-source UI software development kit created by Google for building natively compiled applications for mobile, web, and desktop from a single codebase. It uses Dart as its programming language, known for its efficiency and ahead-of-time compilation, which contributes to Flutter's excellent performance. Flutter's core strength lies in its everything is a widget philosophy, allowing developers to build highly customized and visually stunning user interfaces. It provides a rich set of pre-built widgets that follow material design and Cupertino iOS guidelines. This framework is rapidly gaining popularity for its fast development cycles and expressive UI capabilities. It offers a powerful alternative for cross-platform development. Flutter provides a unique approach to UI creation. Key concepts in Flutter include Dart, the object-oriented programming language used for Flutter development. Widgets, the fundamental building blocks of Flutter UI, including layout, painting, and interaction. Stateless widgets, widgets that do not change over time. Stateful widgets, widgets that can change dynamically based on user interaction or data. Widget tree, the hierarchical structure of widgets that forms the UI. Hot reload, a feature that allows developers to instantly see changes without restarting the app. Mastering Dart and understanding the widget-based architecture are crucial for effective Flutter development. This approach enables developers to create beautiful and performant applications with a high degree of control over the UI. Flutter's ecosystem is growing, offering extensive tools and community support. Backend services for mobile apps. While the mobile app itself runs on the user's device, front-end, many modern applications require backend services to function fully. The backend handles operations such as data storage, user authentication, push notifications, and complex business logic that cannot be performed client-side. Backend services are typically hosted on remote servers and communicate with the mobile app via APIs. Choosing the right backend architecture and technology stack is crucial for scalability, security, and performance. Without a robust backend, many apps would be limited in functionality. It provides the necessary infrastructure for dynamic content and user interaction. This separation of concerns allows for more efficient development and maintenance. Common backend technologies include cloud platforms. AWS, Google Cloud Platform, Microsoft Azure offer scalable infrastructure. Backend as a Service, BAS, Firebase, AWS Amplify provide pre-built backend functionalities like databases, authentication, and storage. Custom backend, developed using languages like Node.js, Python, Django Flask, Ruby on Rails, or Java, Spring Boot. The choice depends on factors like scalability needs, development time, cost, and team expertise. Backend services ensure that data is securely stored and accessible across multiple devices. They enable real-time updates and complex computations. A well-designed backend is integral to a powerful mobile application. Database integration for mobile. Database integration is a critical aspect of mobile app development, enabling applications to store, retrieve, and manage data efficiently. Mobile apps often require both local, on-device, and remote, cloud-based data storage solutions. Local databases provide offline access and faster data retrieval, enhancing the user experience, while remote databases ensure data synchronization across multiple devices and provide a centralized source of truth. The choice of database depends on the app's data structure, scalability requirements, and real-time needs. Effective database management is crucial for app performance and data integrity. It directly impacts the responsiveness and reliability of the application. Understanding different database types is essential. Common database solutions for mobile apps include local databases, SQLite, Android, Core Data, iOS, Realm, Room, Android ORM. These are ideal for offline capabilities. Remote databases, Firebase Real-Time Database, Firestore, AWS DynamoDB, MongoDB Atlas, PostgreSQL. These offer scalability and real-time synchronization. Developers must consider factors like data modeling, query performance, security, and ease of integration when selecting a database. Proper indexing and optimization are vital for handling large datasets. Secure handling of sensitive user data is also paramount. Integrating a robust database solution ensures that the app can manage information effectively, providing a seamless and reliable experience for users. This integration forms the data layer of the application. API design and consumption. Application programming interfaces, APIs, are fundamental to modern mobile app development, acting as intermediaries that allow different software systems to communicate with each other. Mobile apps frequently consume APIs to access data and functionalities from backend services, third-party platforms, or other applications. A well-designed API is crucial for efficient and secure communication, defining the rules and protocols for interaction. Understanding how to design effective APIs and consume existing ones is a core skill for mobile developers. It enables apps to integrate with a vast ecosystem of services. APIs are the glue that connects various software components. They facilitate data exchange and enhance app capabilities. Key aspects of API design include RESTful principles, using standard HTTP methods, GET, POST, PUT, DELETE, for resource-oriented communication. Data formats, typically JSON or XML for data exchange. Authentication and authorization, securing API access using tokens or keys. Versioning, managing changes to the API over time. Documentation, providing clear instructions for API consumers. For API consumption, developers use HTTP client libraries in their chosen programming language to send requests and pass responses. Handling network errors, managing asynchronous operations, and securely storing API keys are also critical considerations. Effective API integration allows mobile apps to leverage powerful external services. From payment gateways to social media platforms, it expands the app's functionality beyond its local capabilities. Security best practices in mobile apps. Mobile app security is paramount, as apps often handle sensitive user data and interact with various network services. Implementing robust security measures is essential to protect user privacy, prevent data breaches, and maintain user trust. Security considerations should be integrated throughout the entire development lifecycle, not just as an afterthought. Neglecting security can lead to severe consequences, including financial losses, reputational damage, and legal liabilities. Developers must be vigilant against common vulnerabilities and adhere to industry best practices. A secure app builds confidence and ensures compliance with regulations. It is a non-negotiable aspect of modern app development. Key security best practices include secure data storage, encrypting sensitive data stored on the device and in the cloud. Secure communication, using HTTPS, SSL, TLS for all network communications. Authentication and authorization, implementing strong user authentication and proper access controls. Input validation, preventing injection attacks and other vulnerabilities by validating all user inputs. Code obfuscation and tampering detection, protecting against reverse engineering and unauthorized modifications. Regular security audits and penetration testing, identifying and fixing vulnerabilities proactively. Minimizing permissions, requesting only necessary device permissions. Adhering to these practices helps create a resilient and trustworthy mobile application. It safeguards both the users and the application itself. Continuous vigilance and updates are vital for maintaining security. Testing mobile applications. Thorough testing is an indispensable phase in the mobile app development lifecycle, ensuring that the application functions correctly, performs optimally, and provides a seamless user experience. It involves identifying and rectifying bugs, performance bottlenecks, and usability issues before the app is released to the public. Various types of testing are conducted, including functional, performance, usability, and security testing. Comprehensive testing minimizes post-launch issues, enhances user satisfaction, and protects the app's reputation. Rushing this phase can lead to a poor user experience and negative reviews. It is a critical step to deliver a high-quality product. Effective testing is a continuous process throughout development. Key types of mobile app testing include unit testing, testing individual components or functions in isolation. Integration testing, verifying interactions between different modules or services. UI testing, ensuring the user interface behaves as expected across devices. Performance testing, assessing responsiveness, stability, and resource usage under various loads. Security testing, identifying vulnerabilities and potential threats. Usability testing, evaluating the app's ease of use and user satisfaction with real users. Compatibility testing, ensuring the app works across different devices, OS versions, and screen sizes. Automated testing tools and frameworks are often used to streamline these processes. A well-executed testing strategy is vital for delivering a stable, reliable, and high-performing mobile application. It ensures the app meets all quality standards. Debugging and performance optimization. Debugging is the process of identifying, analyzing, and resolving errors or bugs in an application's code. It is an inevitable part of software development and requires systematic approaches and effective tools. Performance optimization, on the other hand, focuses on improving the app's speed, responsiveness, and resource efficiency. Example, battery usage, memory consumption. Both debugging and optimization are crucial for delivering a high-quality, user-friendly mobile application. A slow or buggy app can quickly lead to user dissatisfaction and uninstallation. These processes ensure a smooth and reliable user experience. They are continuous tasks throughout the app's lifecycle. Effective debugging techniques include using IDE debuggers, setting breakpoints, stepping through code, inspecting variables, logging, printing messages to track program flow and variable states, error reporting tools, integrating services that capture and report crashes in production. Performance optimization strategies involve code profiling, identifying performance bottlenecks in the code, memory management, optimizing memory usage to prevent crashes and slowdowns, network optimization, reducing data transfer and optimizing API calls, image optimization, compressing and efficiently loading images, battery optimization, minimizing background processes and CPU usage. Mastering these skills is essential for creating robust and efficient mobile applications that provide a superior user experience. They are key to an app's long-term success. Deployment to app stores, iOS. Deploying an iOS application to the Apple App Store is a multi-step process that requires careful attention to detail and adherence to Apple's strict guidelines. Before submission, developers must ensure their app is fully tested, optimized, and meets all technical and content requirements. This includes having an Apple Developer Program membership, configuring app metadata, and preparing screenshots and promotional videos. The submission process involves using Xcode and App Store Connect, Apple's web-based portal for managing apps. Understanding each step is crucial for a successful review and approval. It ensures the app becomes available to millions of iOS users. This phase marks the culmination of the development effort. Key steps for iOS app deployment. Enroll in the Apple Developer Program, required for publishing apps. Prepare your app for distribution. Configure app identifiers, certificates, and provisioning profiles in Xcode. Create an App Store Connect record. Set up app metadata, pricing, availability, and privacy details. Upload your build. Archive your app in Xcode and upload the build to App Store Connect. Submit for review. Provide detailed information to the review team, including a demo account if necessary. Address feedback. Respond to any issues raised by Apple's review team. Release your app. Once approved, choose to release it manually or automatically. The review process can take several days, and rejections are common if guidelines are not met. Patience and meticulous preparation are key to navigating this process successfully. A smooth deployment ensures your app reaches its target audience. Deployment to app stores. Android. Deploying an Android application to the Google Play Store involves a similar but distinct set of steps compared to iOS. Android offers more flexibility in distribution, allowing developers to publish apps not only on Google Play, but also on third-party app stores or directly via APK files. However, Google Play remains the primary and most trusted distribution channel. Developers need a Google Play developer account and must adhere to Google's Play Console policies and guidelines. Preparing the app for release includes signing the application, optimizing its size, and creating compelling store listings. Understanding these requirements is essential for reaching the vast Android user base. It ensures a smooth and successful launch. This process is crucial for app visibility. Key steps for Android app deployment. Enroll in the Google Play Developer Program. A one-time registration fee is required. Prepare your app for release. Generate a signed APK or Android App Bundle (AAB). Optimize resources and obfuscate code. Create a Google Play Console listing. Provide app details, screenshots, feature graphics, and a privacy policy. Configure release tracks. Choose between internal testing, closed testing, open testing, or production release. Submit for review. Google's review process typically focuses on policy compliance and security. Address feedback. Make necessary changes based on Google's review comments. Publish your app. Once approved, the app becomes available on the Google Play Store. The Android deployment process often provides faster review times and more iterative release options. However, maintaining compatibility across a diverse range of Android devices can be challenging. A well-prepared submission increases the likelihood of quick approval. Monetization strategies for apps. Monetization strategies are crucial for generating revenue from mobile applications, transforming a successful app into a sustainable business. Developers must carefully consider various models to find the best fit for their app's content, target audience, and business goals. Choosing the right strategy impacts user experience, app adoption, and long-term profitability. A well-thought-out monetization plan is integral to the app's overall business model. It ensures the app can cover development and maintenance costs. Understanding these options is vital for commercial success. This section explores the most common approaches to earning revenue from mobile apps. Common monetization models include paid apps. Users pay a one-time fee to download the app. Freemium model. The basic app is free, but premium features or content require a subscription or in-app purchase. In-app purchases, IAP, users buy virtual goods, extra lives, or premium content within the app. Subscriptions, users pay recurring fees for access to content or features, e.g., monthly, annually. In-app advertising, displaying ads within the app, often through ad networks. Affiliate marketing, promoting other products or services within the app and earning a commission. Sponsorships, partnering with brands to integrate their content or branding. Many apps combine multiple strategies to maximize revenue. Balancing monetization with user experience is key to avoiding user churn. A successful strategy aligns with the app's value proposition. App marketing and promotion. App marketing and promotion are essential for increasing visibility, driving downloads, and attracting a loyal user base in a highly competitive market. Even the best app can fail without effective marketing. This involves a combination of strategies to reach the target audience and convince them to download and use the application. Marketing efforts should begin even before the app's launch to build anticipation. A well-executed marketing plan is crucial for standing out from the millions of apps available. It ensures that potential users are aware of the app's existence and value. This phase is as important as development itself for commercial success. Key app marketing and promotion strategies include App Store Optimization, ASO, optimizing App Store listings, keywords, title, description, screenshots to improve visibility. Social media marketing, engaging with users and promoting the app on platforms like Facebook, Instagram, Twitter. Content marketing, creating blog posts, articles, and videos about the app's features and benefits. Influencer marketing, collaborating with relevant influencers to reach their audience. Paid advertising, running campaigns on social media, search engines, or mobile ad networks. Public relations, generating media coverage and press releases. Email marketing, building an email list and sending updates and promotions. A multi-channel approach often yields the best results. Continuously monitoring marketing performance and adapting strategies based on data is vital for sustained growth. Effective promotion ensures your app finds its audience. Maintenance and updates. Post-launch maintenance and regular updates are critical for the long-term success and sustainability of any mobile application. The mobile landscape is constantly evolving, with new operating system versions, device models, and security threats emerging regularly. Apps must be updated to ensure compatibility, fix bugs, improve performance, and introduce new features. Neglecting maintenance can lead to app instability, security vulnerabilities, and a decline in user engagement. A well-planned maintenance schedule keeps the app relevant and competitive. It demonstrates a commitment to user satisfaction. This ongoing effort is vital for retaining users and extending the app's lifecycle. Key aspects of app maintenance and updates include bug fixes, addressing reported issues and crashes to improve stability. Performance enhancements, optimizing code and resources for speed and efficiency. OS compatibility, updating the app to support new iOS and Android versions. Security patches, implementing fixes for newly discovered vulnerabilities. Feature additions, introducing new functionalities based on user feedback and market trends. UI/UX improvements, refreshing the user interface and enhancing the user experience. Library and SDK updates, keeping third-party dependencies current. Regular communication with users about updates and new features can also foster a stronger community. An active maintenance strategy ensures the app remains reliable, secure, and valuable to its users. It is an investment in the app's future. Emerging trends in mobile development. The mobile development landscape is constantly evolving, driven by technological advancements and changing user expectations. Staying abreast of emerging trends is crucial for developers to remain competitive and create innovative applications. These trends often dictate future directions for user experience, performance, and integration with other technologies. Embracing new paradigms can open up new opportunities and markets for mobile apps. Ignoring them risks falling behind in a fast-paced industry. This section highlights some of the most significant and impactful trends shaping the future of mobile development. It provides insights into where the industry is heading. Key emerging trends include artificial intelligence, AI, and machine learning, ML. Integrating AI for personalized experiences, predictive analytics, and intelligent features. Augmented reality, AR, and virtual reality, VR, creating immersive experiences for gaming, education, and retail. 5G technology, enabling faster speeds, lower latency, and new possibilities for real-time applications. Internet of Things, IoT integration, connecting mobile apps with smart devices and wearables. Foldable devices, designing flexible UIs for new form factors. Voice user interfaces, VUI, incorporating voice commands and assistants for hands-free interaction. Blockchain technology, enhancing security and transparency in mobile transactions. These trends are transforming how users interact with mobile apps and expanding the scope of what mobile applications can achieve. Developers who adapt to these changes will be at the forefront of innovation. Future of mobile app development. The future of mobile app development promises even greater integration, intelligence, and immersion. As technology continues to advance, mobile apps will become more personalized, predictive, and seamlessly embedded into our daily lives. The lines between mobile, web, and desktop applications will blur further. With unified experiences across all devices, developers will increasingly focus on creating context-aware applications that anticipate user needs and provide proactive assistance. The emphasis will shift towards more intuitive interfaces, potentially moving beyond traditional touchscreens to voice, gesture, and even brain-computer interfaces. This evolution will demand continuous learning and adaptation from developers. It presents exciting challenges and opportunities. A mobile app will remain a central hub for digital interaction. Key areas shaping the future include hyper-personalization, apps learning user preferences to offer tailored experiences, ambient computing, devices and apps working together invisibly in the background, edge computing, processing data closer to the user for faster responses and enhanced privacy, progressive web apps, PWAs, bridging the gap between web and native apps with enhanced capabilities, sustainable development, focusing on energy-efficient apps and ethical AI, low-code, no-code platforms, empowering more individuals to create apps with minimal coding. These advancements will redefine what a mobile app truly is, pushing the boundaries of functionality and user interaction. Developers will need to master new tools and paradigms to thrive in this evolving landscape. The future is bright for innovative mobile app creators.